Welcome back, data leaders, Python learners, and my dear friends to Insight Builder channel. Mastering data modeling with AirBnB Dataset on your own Postgres database. A practical guide to dim and fact tables. In this video, we are going to see how to push the data and make it fit inside the modeled tables. How it starts. The data modeling has a specific objective. We need to connect the data in the table with diverse dimensions, and we want to query them effectively. We need to ensure that the amount of data that is checked or touched during the query is limited. Subsequently, we need to increase the speed of the query. This is the primary three objectives that we have when we start modeling our tables. You will understand it why in a couple of minutes. In this case of Airbnb hotel, Airbnb datasets, we are going to do the data modeling to answer questions like which hotel is having highest revenue, how their pricing is correlated with the review rating, what is the number of reviews or the review quantity each property or hotel has, on which date there were more bookings. Like this, we can do and answer a lot of questions. Before we start doing the modeling, we have to understand what are the types of schema available. We have the flat schema, that is the schema that is useful for small and simple applications, which is not having any kind of connectivity. We have a hierarchical model, which is similar to the XML and JSON models that we see in our regular day-to-day activity. And then comes the network model, where each and every table is a network of connections. And then the relational model that we are currently using in our relational database and object-oriented programming. And finally, the star schema and snowflake schema. This has a similarity with the network model, but the star schema is going to have one particular table as the center of connectivity, that is called as a fact table, and the snowflake schema may have more than one particular table, and it will have more, it's kind of a hub and spoke model in case of snowflake schema. Let us start thinking about the star schema for a moment. Star schema is a design approach for storing and analyzing massive amounts of data, which can be segregated into facts and dimensions. The question here is how to know what is a fact and how to find out what is a dimension. Fact is usually a numerical data point that drives the business ahead, like the revenue, the profit, the number of bookings, the number of reviews. All this are kind of a fact that is driving the business ahead. Dimension, on the other hand, is the various features or the parameters that the business is working on, because you can think about the dimension as the products that the business has, the properties in this case, the features of the properties or the product. All this comes under dimension. And even the customers and their types, the end user also can be a dimension, because end users are going to be in variety of types. All these kinds of entities that can be categorized or can be used as categories are dimensions. This will be evident when we start looking at the table. The fact table would contain information about the number of units sold, and a corresponding dimension table would have the colors of those cars. This is an example. So the car color will be in the dimension of the color, while the sales of each of this color will be under fact table. How to start data modeling? The Airbnb dataset. First and foremost, we have to get the schema of the existing Airbnb dataset and take a look at it. We can do that by directly looking at the Postgres database. using the DBeaver tool. I'll be showing you in a couple of minutes how to do that, and you will be astonished at the power of DBeaver. Second, dim tables and fact tables are already in the schema. In fact, the Airbnb data set has been given to us already in this format, dimension tables and fact tables, but they are not perfectly modeled. So we can remodel them. How? Before remodeling, we are going to connect them in this part of the video. Understand the schema and decide how to connect the fact table and the dimension table. Which columns to connect? That is the major decisions we will be taking. And think and explain how the final schema will help in improving the OLAP or online analysis process. This steps that we are going to take also has additional questions that we need to ask. As you see, once you get the data set in your hand, you need to ask a lot of questions. This is the very important step regarding the data modeling aspect. The more understanding you have about the data, like what are the main entities or concepts in my application or the data set. So in Airbnb dataset, if you have followed all the videos till now, let me go to the Internet Explorer. If you have come to this video directly, I would suggest that please visit my playlist where I explain the step-by-step process from the beginning from the step where you establish your Postgres database server till the ingestion, understanding the SQL, major SQL DML queries, then DDL queries, and now we are going to go to the data modeling. This video is explaining the data modeling aspect of the entire database and SQL query series of videos. So kindly take a look at least these 3 videos where you understand how to get the data into the database and start querying with it. Let us go back to the presentation. As I was explaining, we need to understand all these things, and when you go through all those videos, you will understand that listings, reviews, date and day details are the major entities in this Airbnb dataset. The next question is, how do they relate to each other? The reviews, the customers, the properties, the hosts and the listing, how they are brought together. Let us take a look at the tables. You see the 6 tables here, and this this particular table has 90 columns. Can you believe it? And that's why I couldn't fit it inside the single particular slide. And even if I take 3 or 4 slides, still I will not be able to list all the columns here. But the database has no issues of such a limitation. It will take how many ever columns you give and it will neatly store it. What we are going to do is, in this case, we have a simple tables given to us that we ingested from our Kaggle notebooks, and then we are going to connect these tables. So all these tables, I got it. I did not manually type them. I got it from DBeaver. I will show you how to do that. And next is what is the interesting part. We are going to convert this mess into this data model. All we have to do is we have to find out how to connect these tables together. And this connection that you are seeing here also will be done through the commands that we are going to provide to the PostgreSQL database. Coming to the important aspect. The important aspect is that you practice. The point of sharing you this particular kind of the data model that you can achieve this data set through, let us go back to the to the browser for a moment, by providing you the ways to get the PostgreSQL database on your own, so that you don't need to be concerned about any of the cost or any of the additional charges that might incur, and you can play with as easily as possible along with the dataset. You can take the look. I will be sharing the dataset location also in the description below of this video, and you can easily come and practice. The major point that I want to insist again is that you guys can practice on creating the data model and start playing with the data. The most important point is that until unless there are certain concepts, it's in database especially, I will be showing it in this video, that it's not about just doing the things in the right way. You have to do the things in the wrong way to find out what is right. And it is possible when you have your own database, you have your own data set, and you have your own tables. That is the beauty of it, right? And you should have your own tables that is extremely large. This is also an important point. The table should be large enough, the column should be big enough that you are intimidated by it. Okay, you might be surprised that why am I telling this? Because the moment you actually conquer that, that anxiety, that how am I going to model this data set, then you will actually start modeling the data set in a very, very efficient way. You'll see that in a moment how we are going to do that. So I hope you like the content, and do like this video and share this video ahead. Subscribe to my channel so that you will get the updates whenever I am uploading new videos. The point again I will insist is to practice. So how am I going to help you practice is by showing you. So let us go to the DBeaver right now without further delay. We are going to move from this mess to this data model. Full screen and DBeaver. So this is the DBeaver that I have already introduced. If you have not gone through the earlier videos, I would suggest that please go through this video, especially this video where I introduce a DBeaver tool, and then these two videos where I go through the process of establishing constraints by using DDL queries, data definition queries. This will actually bring you up to speed. You might be knowing about basics of SQL. If you want to come up to speed with DBeaver and the DDL queries, then these three videos will help you. Let us go to the full screen again and let us start the activity. Before we start the activity, we need to do some checks. The first and foremost check is that you have to ensure that your database is connected. If your this can be done by checking the edit connection and then give the appropriate host name here, and you have to check it from the AWS EC2 or your own cloud service providers the compute instance, and then update the host name here, and then test the connection. Once you test the connection should go through and you should get a OK. So it is actually reading the database data types and it will say it is connected and OK. So that is how your connection is ensured that it is perfect. What we are going to do first and foremost is that we are going to get the ER diagram. ER diagram in DBeaver is called as a entity relationship diagram. What is entity relationship diagram? You'll see that in a second. The tables that I showed you in the presentation, I had actually collected it directly. Yeah, you see this is the table that I was showing you, the 90 column table, and this is how long it is, and these are the other tables that I have. These tables are right now not connected. What we are going to do is we are going to take this table and we are going to connect it like this. Okay, this is actually called as data modeling. Okay, before we let us go back to the DBeaver again. Usually what happens is that data modeling is an important task when you want to push the data inside first. Okay, in our case we already have the data in our database. Let me actually show you the tables already available. So how to check the tables? You can actually go here and you can click on this. You will see the tables here. There are almost 6 tables here. These 6 tables already have the data also. You see the memory here. This already has the data. In reality, when you are actually designing the data model, the data is not inside the table. The data is somewhere else. You model the tables and then you push the data inside. However, in this case, we already have the tables with us. So what to do? First of all, we need to check what are the constraints on the tables. So to check the constraints, we can use the information schema.table constraints. This is one of the catalog information, that metadata information that is provided by the Postgres database. So let me execute. I am asking for the table name, the constraint type, and the table schema. and I'm going to execute this, and you see that I have in fact a very simple set of checking here. I'm checking that I need to have that neighborhood should not have null, reviews I hope you are able to see, and listing should not have null, but there is no any kind of foreign key or primary key available in this particular table. This is very clear from this constraints that you have received. Now, how to, before we go any further, we have to understand how does foreign key and primary key make any constraints. Okay, so for that I am going to first of all show you some of the supporting commands where we check it. So first and foremost, what you are going to do is we are going to take listings table. Let us take a look at the columns inside the listings table by using from select l dot star, and here in DBeaver you can actually look at the table columns directly. When you use the alias and when you press the dot, you will get the list of columns inside the table. The point here is that we need to find the columns that can act as primary keys and secondary keys. Okay, which of these columns can be primary keys and which of these columns can be secondary keys? And first and foremost, we have got the table with us. Okay, so this is in the reverse way it happens. As I was explaining, in the regular format, when you are going to do the data modeling, you will have to model the entire table by yourself. But in this case of AirBnB dataset, the table has been already provided to you. And what we are going to do is we are just going to do a star, and let us limit the output by 5, and let us execute this. And you will see that it will take a moment for my data to connect. And in the meantime, let me go and let me go to this area. So you see that already all of the columns are available here. We have to connect the listings. So listings has got, I think I can zoom in. Yeah, I can zoom in here. I hope you guys can see it well. So listings column has got the necessary listings column here, has got the ID, name, host ID, host name, neighborhood, all these things. So neighborhood could be a separate, it's a separate dimension table. Host ID, host name is again a separate dimension table. The reviewer details are again separate dimension table. You can see all these tables separately here. And also, the most importantly, the calendar table. This calendar table has got the listing ID, and it has the date available and the price based on the date of interest. The major point is that even if you come here to the listings details, the entire details of the listing, we have huge amount of features. As I was explaining, each product will have a lot of features, and like that every listing will have a lot of features like the city, zip code, the country, latitude, what is the type of fees that is provided, and whether it is available for the next 90 days, 50 days, 60 days, whatever it is, and the review scores, license. All these things are dimensions. So as we saw, currently we have this major very big dimension table which has its own ID, and this ID, as we slowly review these tables, you will understand that okay, we can connect these tables with the listing tables, because listing table contains the price, it contains the number of reviews. These 2 points are the major drivers of business: price and number of reviews, right? These are the major drivers, and this particular table contains it. And this particular table also contains the ID. And how to connect this ID with the listing ID in this table? Also in this table, we have listing ID in this table, and again we have ID in this table. So all these IDs can be connected to this one table. That is how you will create this connection. That is how you are going to create this connection. All these tables that you are seeing, the listing ID has the column here. This listing ID columns will be connected with this main column. And after that, we can say that our data has been completely modeled. We are going to go through the step-by-step process of connecting the listings table with the other tables, or we can say the other way. We are going to connect the other tables with the listings table. For that, we need to first of all have two things. Okay, we have to have the primary keys for each of these tables. We have to first of all assign primary keys for each of the child tables, and we need to have a primary key in listings. Then only we can attach these two tables. That is how it works. Without a proper unique column that can be used by the other table, we cannot connect the table. You will see that in action in a couple of minutes right now. So I will start connecting each and every table one by one. Okay, so first and foremost, let us get the primary key assigned for listing. Okay, we are going to make the ID. Let me go back to the full screen. And I am going to make this particular column, ID column, as primary key. Okay, you might be wondering, okay, why am I making this ID column as primary key? The primary key has to be unique. First and foremost, it has to be unique, and it should not contain any null value. How to find this? Let me first of all test these things. You have to test. Okay, first and foremost, what is the constraint? That the primary key column, let me type it, primary key column must be unique, must have unique constraint, and must not have null values. This is the important constraint. How to test this? Okay, so first way to test this is that we need to know how many rows are there inside the listings table. So for that, we can use from listings, and then we can count. So we can select and count the listings. Once you count this, you will actually get the answer here. So it will connect to my database, and it will give me the answer. So the point is, once we get the answer, then we can take additional steps. So we got 20,000 rows are there. Okay, 20,030 rows are there in this. 20,030 rows are there in this table. Next, what we are going to do is we are going to count the unique IDs from. Let us go down again from listings. Okay, I'm going to count. Let me show you first the unique data, unique distinct, and I'm going to say l.id, and I'm going to execute this. So the moment you see, I get all the IDs here, right? I want to ensure that the ID column is containing unique values. Unique values means each row here should be unique number. It will not be same as the other number. How to check that? If I take the same above query, and if I count it, okay, if I count the distinct numbers in the distinct number of elements in the column, it should be same as the count of rows that we got from this listings table. Then we can ensure that the column is having unique value. So I should get 20,030. So here also, when I executed the value, I got 20,030. I am executing this. So let me actually give as listings row. Okay, so that it will be easier for you guys to understand. Count distinct. This is how you give alias. Okay, So when I execute this, you say count listings as 20,030, and when I execute this particular, sorry, just a minute. When I execute this particular query, you see that I get 20,030 as the count. This is how you ensure that yes, this particular column ID is unique and it is not having any null values. Now that you have ensured this, what we are going to do is we are going to make this column as primary key column. In order to make this column as primary key, in reality, when you start doing any of the data sets and when you are given a task, what you will do is you will do this activity first. So when you create the table itself, when you create the table, for an example, when you create table listings, okay, you will create the table listing and you will start by creating the ID. So you will start by creating ID, you will give integer, you will say unique. You don't need to say unique actually, but you can still say unique primary key. This is how you will start creating the table, and then you will give the other names. So you will give the host listing name as varchar, etc. So you will start creating the table, right? In this case, what has happened is we already have the table. So once you have the table, what you can do? We can do by altering the table. So we say alter table listing. We are going to alter the table listings, and what we are going to alter? We are going to alter the column, and we are going to add a constraint. So add constraint, it's straightforward. You say add constraint and you say the constraint name. So I am going to give the constraint name as list pk, and the constraint type that you are going to add is primary key, correct? And after this, I need to provide the column name here without any quotation, any double quotes. You have to give the name directly. And once you execute this, it will say that updated rows is 0, but query has been executed. Okay, you will get the output like this. After this, we can go and check the constraints again. So let me copy this value. Okay, and let me bring it down here. So you can, once you understand these things, you can copy paste. Initially do type, and now you see that we have the primary key constraint here for the tables listings. We have to start working on each of these table and each of these tables that we have here, and we have to create the primary keys now. So that is what we are going to do next. The point I am trying to make here is that if you don't check, so assume that you don't check. Okay, let me show you what will happen. Assume that you don't check any of these things. You don't check the count, you don't check the whether it is distinct or not. Then if you try to create a primary key, what will happen? I will show it to you right now in case of neighborhood table. So let me actually take the neighborhood table. Okay, and let me first of all select and show you the table. It's a very small table, so it's not a very big deal. So you see that I am getting the neighborhood table. Okay, and in this case I can clearly see that okay, there are 21 rows and there are 21 different neighborhood names. So all I have to do is very simple. I don't need to even worry about it. I can say alter table neighborhood and add constraint neighbor bh. Okay, let us say bh pk. Pk is for primary key, and we say primary key id is neighborhood. Okay, and once you execute that, it will go through, no issues here. Okay, but the challenge is that there is a similar neighborhood in here. You see this table, you see this listings detail. Inside that you will find that there is neighborhood also, but this neighborhood is not properly arranged. So if I try to create a primary key on this particular column, you will see that it will fail. So why it will fail? First of all, it is not unique. So let me execute it and show it to you so that it will be clear for you why it will fail. So let us actually say, first of all, select, no, we should not start like that. We have to start from listing details, ld select ld dot neighborhood and ld dot id. Just a minute. Then if we give a limit of 5 and execute this, excuse me, you'll see that it will give us, you will see that this particular column is not unique. And if I try to alter, so we see that we have repeating names in this particular column, neighborhood. Now if I alter the table, alter table listing details, and I'm going to add a constraint, add constraint, let us say list. Anyway, it is not going to work, but still we need to properly give the name, primary key. If I try to give a primary key on this neighborhood, what will happen is it will throw an error. Let me execute this, and you see that it did not execute. And if you click on this particular icon here, you will see the execution log, and click on this execution log, you will see the error. Could not create unique index, list neighbor pk, key neighborhood is duplicated. So what will happen? So what you saw, what you experienced this error is because that when you create a table with the primary key constraint, okay, you are telling that the data that is going to come into that particular column has to be unique only. It cannot be duplicated. If it is going to be duplicated, it will fail. Okay, so here we already have a table. We already have this table, right? We can check whether this particular column is unique or not by actually creating a primary key. But see, primary key will not work. Okay, however, I can actually make this as a secondary key. So this I will show you. So this is actually important. What happens here is that, yes, this neighborhood, where it is, this neighborhood cannot be primary key, but the data, the column that comes into the neighborhood and neighborhood cleansed column can or has to be one of the neighborhood that is from this particular table. So let me go back to these neighborhoods that you see here. That should be one of the neighborhoods that is inside the neighborhood table. It cannot be any other neighborhood, right? There are only 21 neighborhoods, and I want to ensure and I want to constrain the listings detail table that, okay, the column listing details column, neighborhood and neighborhood cleansed column should only contain the names that are in the neighborhood table. How can I do that? That is where the concept of secondary key comes. Okay, how are we going to create the secondary key? The first and foremost secondary key that we are going to create is for this neighborhood. We will directly create for neighborhood first and see what happens, whether it works or not. Okay, we saw that primary key did not work. Okay, good. We learned that, okay, it cannot be primary key, but let us see whether it can be secondary key and can it refer to this primary key, the neighborhood. Okay, neighbor, and also one more important point, I missed this point. If a particular column, so for an example, if I have to make this column as a secondary key, that becomes a reference for this column. Okay, this is the table, this is the main table or the child table that I'm going to talk about, and this is the mother table or the main table. Now if we want the child tables column, okay, to refer to the mother tables column, then first and foremost the mother table column should have a primary key. Okay, without that we cannot establish a secondary key. It is not acceptable. And second point is that the column that we are going to use as reference should be unique. So I am going to take neighborhood cleansed column and I am going to refer that to neighborhood column. This column has to be unique. And in our case, we know that it is unique, right? We already checked it. So here we already checked that there are unique names, 21 names. So this should work. Let us try now that we are going to say alter table listing details, add foreign key, I'm going to use neighborhood. Okay, this will actually error out. However, I want to show you why it is erroring out. References neighborhood is a table here. Okay, there are two things with the same name. Neighborhood column is also there, neighborhood table also there. Inside the neighborhood table, there is a column called neighborhood that we are going to refer. So this is the neighborhood table. Inside this, there is a neighborhood column. So we are going to refer that to this column in listings table. Let us execute this. You will see that it will again error out. I told you it will error because it says that insert and update on table listing details violates foreign key constraint. The detail neighborhood indish BERT is not present in neighborhood table. Okay, it is telling that one of the values that which is inside the neighborhood column in the listings details table is not inside the neighborhood table. Let us check that. Okay, let us actually just a minute. Let us actually execute the neighborhood here, and if you actually scroll up and down, there are only 21 names, and we see there is no name called as Indish but here you see that this is a very big name, and second part of the second is Indish but. So there is something wrong in the way the listings detail has been created. After you review, this also can happen in your cases also. So once I reviewed it, I found that there is an additional column called as neighborhood cleansed. If I execute this same alter table on neighborhood cleansed, okay, I'm going to assign listing details for neighborhood cleansed. Okay, now if I execute this, this will execute. This will execute because the neighborhood cleansed column contains only the values that is inside this neighborhood table. Okay, so you understood this point. This point is very important because we are trying to connect. So now if I actually come here and if I refresh this, let me close this. Okay, and let me refresh this table, refresh this like this, and let me also refresh this also, and then open the view diagram again. If you see the view diagram right now, there will be a connection between the neighborhood table and the listings detail table. That is how the connection diagram starts. Okay, the moment you start connecting the table, it is taking some time because it is checking everything. Okay, the moment you are able to connect it, then you will understand how it works. Okay, so here you see that I have already connected the neighborhood table. Okay, now you are seeing that there are multiple tables here. What is happening? So why is this error happening? Okay, the point here is that the tables inside the database can get sometimes corrupted. So when such a error happens in your case, all you need to do is refresh it. It will work properly. Now the point here I wanted to show is that it is connected. Okay, but it is showing me there are two listing details table, but there is only one table. Okay, there is not two tables. There is only one table. And like this, we can connect the listings detail table, and I will show it to you as a complete connected data in a moment. So after I gave similar kinds of constraints, now each of these tables like reviews, the review details, the calendar table, the neighborhood group table, and this particular ID also has been linked. And you see that whenever I am clicking a particular column, the connection is becoming green. That means this is the connection that is connecting with this column and this column. That is how the constraint has been established. So this is how you can use ER diagram inside the DBeaver to analyze how the data table or the data model has been done when you are given a new set of database. That is one of the ways of looking at it. If you look at the queries that has been used, I have used, so till when I showed you the last step, I had created the foreign key till here. The foreign this particular query had failed. After that, I had executed all this queries. So 1, 2, 3, 4, 5, 6 queries I had executed, and with these 6 queries, I had got all these connections established. And this particular way of connecting the tables and creating the data model is the major activity that is actually done by using the foreign keys and primary keys. Understanding this concept is very, very important. When you are working on OLTP, that is online transaction process, or online analysis process, that is OLAP, understanding these key points are important. You actually don't need to understand how the joins are going to work. We will look into the joins in the next video. Okay, we will see how to make these table now that the tables are connected, right? The listing ID in review is connected with the listing ID in the listings table. And same way, if I look at the neighborhood group, okay, if I click on neighborhood column is connected with both listings details as well as listings also. It is connected. You see both the things connection in green here. If I click here, the listing, so most of the places listing ID has been the major column. Okay, so this particular table is very, very important. This is the fact table, and these are all dimension tables. Okay, when we actually look at this, we have to still modify these tables. These are all not exactly matching the dimension table specification that you might want to look. So why is the price here? This price should not be here in the dimension table. Why is the price there? But in this case, the price is in this dimension table because price acts as a category here. Okay, the date is a category, availability is a category. So that is why this is called as a calendar dimension. Similarly, what is review details doing? So reviewer ID, reviewer name, reviewer comments, all these are separate categories on a given date. And each of the review will have its own ID, and each ID row will have listing ID that is connected with the listings table. This understanding has to be important. Okay, what will happen? Assume just for a moment, think that I have reviews detail and a new reviewer comes. Okay, let us go to the table. I will explain to you why this is important. So let us go to the table and let us say from reviews. Okay, and I say select R. Okay, this yeah, let us say review details. Actually, reviews details RD and star. Okay, and I say limit 2. Okay, once I execute this particular query, it will go to the review details and get me the review rows and columns. But After we get the reviews rows and column, we might want to add additional review. Okay, we are getting an error. Let us see what is the problem. Okay, so this kinds of error can happen when your backend is having, when your internet connectivity or your database server, something is wrong. Okay, let me try again in a moment. Give me a second. So I'm back. Sorry for the interruption. We see that when we execute the review details and we see there is a column, listing ID, date, etc. The point here is that when I am going to enter a new review, okay, a new user comes, a reviewer called someone named as Alice. Let us say Alice comes back, okay, and she has a ID of 12,798, and she comes back on, say, let us say 2022. We are in 23, and she comes back, and she is going to give a review, and she wants to give a review for a listing ID. She has to select a listing. And when she selects the listing, that listing ID has to be among these listing ID. So let me do a select again. So from listings, so if I say listings, and if I say select l.id, and let us say, let me give only a limited example, so the listing ID that it can be selected has to be among these set of numbers. So she or he cannot select anything apart from this listing ID, because this review details table has been connected to listings table using the reference. So what is the reference that we have given? We have actually given the reference of listing ID. This listing ID column in review details is connected with ID column in listings. So I cannot enter any other listing number that is not inside the ID column, in listings table. So let me go back to the ER diagram and show it to you. Just a minute. As you see in this ER diagram here, this listing ID here in reviews detail table is connected with listings table through the ID. So whatever listing ID that is coming or that is inputted, it is entered or updated in the reviews details table has to be one of the IDs that is inside the column listings, column ID in the listings table. This is the important point you have to take away. Same way, if you are going to reviews also, the listings ID that is going to be entered in reviews should be one of the IDs inside the listing. In calendar also, when you are going to book a particular listing, that particular listing has to be there in the listing ID, correct? Or else there should not be any booking at all, because it is not listed, the number is wrong. And when we are going to check the details also, listing details, again it has to be the listing details that is actually shown here has to be same as has to be one of the IDs that is inside the listings table. I hope now with this particular set of commands, you have to execute these commands on your own databases and check how the things are working. And you can also try to update. So for an example, let us try updating. Let me take an example and let us try updating the review details, one of the columns. So let us take this from review details, reviews details. I'm going to say, first of all, let us select rd.star, okay, and let us say where rd.listing ID is equal to 2818. Okay, let us first of all execute this, and we see there are lots of reviews available, correct? We want to update one of these reviews. Let us take the review ID 1191. We want to update this review. Okay, so how are we going to update that? Let us just give me a moment. In order to update the rows, we have to use the update command in Postgres. Update, what we are going to update? We are going to update the reviews. We are going to update the review detail table. So let us take a space here. We are going to update reviews details table. And what we are going to change? We are going to set the listing ID. Okay, we are going to change the listing ID, and we are going to change the listing ID to some number, some random number like this. And we are going to set this. We don't know whether this listing ID is inside this. I am sure that this listing ID number is not part of this ID. Okay, this is a random number actually. I'm going to set it where I'm going to set it where review ID. Just a minute. Again, I'm showing you. I am going to set where the ID is 1191. I am going to change the listing ID. I'm going to try and change it. Okay, 1191, right? So I'm going to say where ID is equal to 1191, and if I execute this, you will see that I will immediately get an error. If I click on this error, you will see that insert or update on table review details violates foreign key constraint. Detail listing ID, this number is not present in table listings. So this is how the constraints that we create, these constraints that we are creating here, the purpose is that when we are going to do the additional updates into the table, into the set of tables, it will match, it will check the other tables also. That is why this key is given. But our objective of doing this data modeling was something else, right? We already have the table with us. Then how is this secondary key, primary key going to help us when we are going to analyze the data set? Okay, this is where the point comes. Whenever your data is properly connected, okay, querying the data becomes way more easier for the database. The database will not actually check everything when it is going to query for your analysis process. Your query speeds up. If your database is not connected, okay, if your database is tables in the database is not connected properly, like how I connected right now, and if you query it, the query time will be longer. And here we are having only maximum of 20,000 rows, and maximum it goes up to in case of calendar, it goes up to 7 million rows or 14 million rows in depending on the data set that you are uploading. But if all the rows are very large in number, and if it is not properly connected, then your data retrieval time, the analysis time, will increase drastically. And assume that why will you be doing the analysis? That you want to show the analysis to someone. You want to create a data dashboard. You want to create a presentation that you want to share it with your stakeholders and your customers. At that time, it has to query all this table and give you the final result. And how it will give the final result? It has to check and do the calculation. The database server has to do some work. In order to make the database server to work properly and work fastly and retrieve the query faster, as I was explained here, the subsequent increase in the query speed you will get, and also most importantly, it will reduce the amount of data that is touched. You will understand by doing all this data modeling, you will clearly understand each and every table in detail. Okay, you will know exactly which column. Right now, let us go to the full screen and let us go to the DBeaver table, and you clearly know that, okay, this is the main table. This listings is the main table. The IDs in the listings is what is going to be there in all these tables. And by using this ID, you can clearly filter the other tables more efficiently. Okay, and same way, when you are going to say, excuse me, neighborhood, you can start filtering this table itself more efficiently by using the neighborhood column and also this particular table. Like this, the way of connecting and then executing, and then you can start joining also. Now joining becomes more easy. So you know how to join the tables. If you want to get the reviewer, for an example, you want to get the reviewer ID and reviewer name, and you also want to get the name of the listing and latitude, longitude, etc. Joining it on the listing ID. These two tables you can join on the listing ID, and you can be rest assured that you can get the data out. Same way, you can actually try to work on this table, the listing ID and reviews. Same way, you can work on listing ID and calendar, listings and calendar. So you can actually start connecting all these tables seamlessly using the listings ID as a listings table ID column as the joining column, and you can execute any number of queries and it will execute more efficiently. So all these are the benefits of executing these commands and understanding how these commands actually work at the once you establish the foreign key, primary key, and now if you go and see the number of constraints, you'll see that there will be more constraints in the table. So all these are the constraints. Initially when we started, there were not these many constraints. Now all these constraints have been created in this database and on the tables. This is how we start data modeling, and you see the data modeling in a very different perspective. Whenever you see the data modeling, any of the other data modeling courses, you see they take a particular table, they disintegrate the table, and they create the fact table and dimension table, and then they push the data inside. But the major challenge comes when the data is already available with you, and then you have to create a data model with that particular table. It is a reverse way of thinking, right? You have to work with whatever you have got. How will you do that? And how will you create this fact and dimension table with that data? That is what we have seen in this particular. So we have this table. We have made the connection finally by using our understanding of primary key, secondary key, unique constraint, null constraint, and not null constraint actually. Distinct keyword, count keyword. We have used very simple commands in SQL, and we have done an excellent activity of connecting the tables. So take this video, watch it. The first time you may not understand anything. You have to properly you have to take the DBeaver and start writing the code, start writing the query and check it. Then only you will understand these concepts. It's more of a practical, hands-on, getting your hands dirty kind of a tutorial that you need to execute one by one. So take your time and understand this particular tables, and do the data modeling and try it out. If you have any questions, do leave it in the comment section, and leave a like once you like this video, and subscribe for my channel so that you will get more updates on the videos that I upload. And before I close this video, there are 4 words always I say: practice, 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 practice. See you guys. Have a nice time till the next video.